Welcome back to this video series on nRF Connect for VS Code. In this video, we will learn how to flash an application to a board and also go through the actions and connected devices we use. To flash an application, we first have to connect a Nordic development kit or other development board compatible with our built application. Here I have already connected my nRF 52833 development kit because that is what I readily had on hand, and that is what both of my application's build configuration are set up for. So if we scroll down here, we see that there's indeed an nRF 52833 dev kit listed under the connected devices view. Flashing my application to this board is now very easy. As it is already built, I can simply go to the actions view and click the flash button. We see that the application is being written to our development kit in the terminal here. If we want to erase the board before flashing a new application, we can click the little button on the right here. This is only necessary when flashing a file that might conflict with a file previously flashed to the board. In most cases, using the simple flash is the preferred method, as the files on the board can never be recovered after erasing. When the firmware upgrade is finished, we see that the little LED on the board blinks faster and faster according to the duty cycle on the Blinky PVM sample. If we want to flash a different application to this board, we can simply select the other application we have in our applications view and the correct build for it, and click on Flash. This application is based on the basic threads sample and runs 3 threads in parallel. 1 to toggle LED 0, 1 to toggle LED 1, and a counter that counts the time each of the LEDs has been toggled and writes it to the serial terminal. When we flash this to the board, we see that LED 0 toggles about 10 times for each time LED 1 has toggled. If we open the serial terminal, select the correct baud rate for our board here, we can indeed confirm that strings are being written, and if we stop the terminal, we can confirm that LED 0 has been toggled 10 times as many as LED 1. Let's try to modify this. I'll open the main.c of this application and, for instance, edit the sleep value for the blink function that is used to toggle the 2 LEDs. So I'll set the value for LED 0 to 200, which means 200 milliseconds of sleep between each toggle, and the value for LED 1 down to 400, which means LED 0 will toggle 2 times for each toggle of LED 1. When we click Flash, it automatically rebuilds and flashes this application to our board. It does not do a pristine build now, as we have not changed any of the configuration files, only our main.c file. When the flashing has completed, we see that the LEDs now toggled in a 2:1 ratio, and the serial terminal confirms this by counting twice as many cycles for LED 0 as for LED 1. Be aware that the flash command only applies to devices using a SIGART J-Link, so not the thingies and not the dongle. Since we've already covered the flash button, let's have a look at the rest of the buttons in the actions view. The build button rebuilds the selected application using the selected build configuration. If there are any changes made to the config files, this will automatically be detected and a pristine build will be invoked automatically. A pristine build builds the entire application from scratch with the files from the SDK, while the simpler build only rebuilds the files that have been changed since the last time the application was built. Pristine build can also be invoked manually by clicking this icon, which shows up on the right here when we mouse over the build button. This is only necessary to do manually if you remove or add any configuration files in your project or when you update your SDK. The Kconfig button opens our Kconfig in 3 view. This is a graphical way of configuring the prj.conf file to include the functionality we want to implement from the Zephyr kernel. Checking the different boxes here in the GUI adds new lines to the prj.conf file with an equal to y behind it, which means it is enabled. Unchecking it in the GUI is the same as removing the line, changing the y to an n for no, or commenting out the line. After we made changes, we have 3 options for saving our changes. Save saves changes to the .conf file found in the build folder. This results in only temporary changes that are reverted if a pristine build is made. Save to file saves changes to the existing application configuration's prj.conf file, resulting in permanent changes to our build configuration. Save minimal saves only the changes we made in a new config file, which can be located in a directory of our choice. As we said before, if we make any changes here, build command will automatically invoke a pristine build. Moving on to the debug button, This will automatically flash your application to a connected board and start a debugging session. We'll go through this in more detail in a later video. Then we have the memory report. Clicking the button automatically generates a memory report, a visualization of which parts of your application take up how much of the RAM and ROM on your device. We can click into this pie chart to find parts of our code that take up an unproportionally large amount of capacity compared to their function. This is useful for size optimizing, as we can visually see the size of different parts of our code in relation to each other. Then we have the connected devices view. As we can see, I have one device connected here, the nRF 52833 development kit. Clicking this button resets the board the same way pushing the reset button on the hardware itself would, and the 3 dots brings up more options like erasing, recovering, or renaming the board. For instance, I can rename this specific dev kit so it's easy to see which application goes on it every time I connect it to my PC. If we expand, we can see that the version of the nRF 52833 SoC we have on this board. We can also see which COM port is used for the serial terminal, and clicking the little power plug connects to it. Doing so prompts us to select the baud rate. This will be the correct one by default and brings up the serial output of the board in the nRF terminal here. If we click the power plug next to RTT, we connect to the RTT and nRF terminal if this is enabled on our device. In this case, it is not, so we're not getting any useful output here. I select automatic search and it brings up the real-time terminal output of my device. The advantage of using RTT instead of the serial terminal is that the latter consumes an UART port that you might want to use for something else. The disadvantage is that you always need to have a segregating debugger connected for RTT to work. That was it for the connected devices view. In the next video, we will cover debugging. Happy coding!